Hello, my name is Jacob and I'm joined by Paul and Shiv to present our database systems project titled Whooping Cranes Wayward Ways.
So a little background on the whooping cranes. They're currently an endangered species. Over 50 years ago, there were less than 50 alive total, but today that number has grown over 700. Each spring and fall, the entire population of migratory whooping cranes will fly through the central flyway in Nebraska, generally going over the sandhills, which is an excellent place to spot them. Their main destination is up in Canada, where they will try to get to their breeding grounds.
The goal for our project is to visualize the habitats of whooping cranes in Nebraska, and we expect biological research organizations and bird spotters to be the primary users for our project.
We obtained our data for the whooping cranes from ebird.org. This website contains the spottings of migratory whooping cranes within the US for tracking back to 1900s in years. Using this data, we split it up into seasons of whooping crane spottings. Some of our data is, however, artificial, such as competing species and nature centers. We use this data, this artificial data, to showcase the potential of GIS to improve the living standards through finding overlaps of these areas with whooping crane spottings. This is the ER diagram for our project. It mainly consists of 6 tables to create the visualization of whooping crane migration within Nebraska. The cranes dataset contains the data regarding spottings of whooping cranes. Species dataset contains competing species dataset contains the data on competing species. Cities, roads, and nature centers are all locations within Nebraska. The relation between cranes in Nebraska is lives in, as well as competing species in Nebraska is also lives in. For the locations, they are all contains relations with Nebraska. A majority of these tables have coordinates to identify their location, but if you look, they also have IDs in order to identify the specific locations within Nebraska and the specific spottings. For cranes, they have specifically a time of spotting in order to identify which season this crane was spotted.
The first function we developed was the ability to find where cranes had been spotted in Nebraska based on the season. To do this, we joined our cranes table, which holds the location of each spotting, with our seasons table, which holds the season that each spotting occurred in. By executing this query, we were able to see that the spring was the season with the most spottings throughout Nebraska. As you can see here, spring kind of has a myriad of locations where cranes were found, while summer was an off-season for whooping cranes in Nebraska, where there are much fewer spottings. The second function we developed was the ability to find cranes that had been spotted at nature centers throughout Nebraska. To do this query, we created a dataset with proposed nature center locations in Nebraska. Although these nature centers don't actually exist, this query allows us to highlight regions in Nebraska where there are clusters of sightings. What this looks like in our database are 6 different nature center zones within Nebraska, where the sightings are represented as dots within the zones. In the future, we could further expand on this query by narrowing down the sightings by season. For example, if we wanted to just know which of these had occurred during the spring, we could input that into a further query.
So for our third function, we wanted to do a query where you can see these along the road, or where people might have been able to see them along the road and then report them to us. Now, due to the size and granularity of our map, a single pixel is actually representative of about how far a person can see from a road. With that being said, you can just do a simple x equals x and y equals y query, and you can find where on the map people were able to find these birds. As you can see, there aren't exactly that many. Um, this is mainly because whooping crane sightings, again going back, are pretty rare. There aren't that many left, and they're also easily confused with the Sandhills crane, which makes getting a positive ID on them kind of hard. The other thing we need to talk about is some of the problems we encountered along the way while making this. Um, MLPQ by default will have a display time of 1, and what that ends up doing is that means that if you have time data in your databases, you can only see any entry that has a time value of 1. And this took us a while to figure out, one, what was going on, and two, how to come up with a way to fix it. And what we did is we ended up making another table separate from the main cranes table and their coordinates that had the time values of when these sightings had occurred, what season they were in. Next, there's a very small number of whooping cranes, and getting any conclusive data on them is rather difficult. Well, most of our sightings are actual sightings that have been reported. In order to have enough data, we had to combine every single year we could get our hands on. And I believe the data we're showing is representative of at least 10 or 20 different years.
So, in conclusion, MLPQ is a great way to identify the locations of moving cranes and, by extension, improve their living standards. This constraint database can find intersections between the whooping crane niche and location of nature centers. By finding these intersections, people can find also the intersections between these whooping cranes and competing species, and then they can help to preserve these whooping cranes in these locations by providing for them. One trend that has been noticeable within this dataset is whooping cranes frequently appear during the fall and spring season, whereas during winter they are not as present.